Hello and welcome to Circuit Crust TV. I'm your host, Brian Jenkins. Welcome to Arduino tutorial number 8. Now, so far we've talked about the hardware on the board, powering the Arduino safely and properly. We talked about installing and tweaking the IDE, connecting the Arduino to your PC, and installing libraries. Now that we have the preliminary stuff out of the way, it's time to roll up our sleeves and start talking about actually programming the Arduino to do something other than sit there and look pretty. Now, the world of electronics and microcontrollers is a fascinating but complicated one, especially if you're new to it all. Because of the complexity of this world, at first I wasn't sure where to start. After some deliberation, I came to a decision. First, we're going to talk about how the Arduino toolchain converts instructions you type into the text editor into machine language the microcontroller can understand. A toolchain is simply a set of software tools that work together to complete a task. So, if I were going to hang a picture, for example, the toolchain might include a hammer, maybe a tape measure, and some nails. After we talk more about the toolchain, we'll go over some programming best practices and basics. And after that, we'll take a look at a real program that does something useful and dissect it. Now, rather than crunch all this into one very long video, I decided to break it up into several easily digestible videos. This helps you avoid what's known as information overload, which is a common condition these days, especially among those who try to learn about Arduino and microcontrollers. Let's do this. When programming the Arduino, or anything else, it is possible to write some pretty complex instructions and get the Arduino to do some really cool things. The problem is that a microcontroller, like the ATmega328 on the Uno, can only execute simple, low-level instructions. These simple instructions include things like add variable A to variable B, or take variable B and put it in register X. And to complicate matters, microcontrollers only speak in binary. For those who don't know, binary numbers are long strings of ones and zeros. Maybe we'll talk more about binary numbers another time. The statement here may make total sense to you if you've been working with Arduino for a while, or if not, it may not make any sense at all. Either way, just go with me here for a minute. This is just an illustration which does not require complete understanding of the code. So how does a complex statement like this one actually run on a microcontroller that only knows basic arithmetic, logic, moving, and shifting? How do these statements translate into the ones and zeros that the microcontroller can actually understand? Glad you asked. No, really, I am. This is what we're going to answer now. Microcontrollers are electronic devices. So to speak to one, you need to send electronic signals. That's where binary numbers come into play. A 0 represents low or off, usually 0 volts or close to it, while a 1 represents high or on, usually either 5 volts or 3.3 volts depending on the processor. A good way to think of binary numbers and digital signals is like a single pole light switch in your house. The light is either on or it's off. There's nothing in between. A 0 is off and a 1 is on. Going from complex instructions to simple ones the microcontroller understands requires several layers of software that translate the high-level operations into simpler instructions. Enter the compiler. Compiling a program in Arduino is referred to as verifying. The terms mean the same thing, so throughout these tutorials we'll use them interchangeably. Now, the compiler first transforms the code you write into assembly language. The name of the compiler we'll be using on our Uno is AVR GCC. Now, if you're new to this may sound kind of weird, but try not to get too hung up on it. It's just a name. The assembler, which is built into the IDE with the compiler, then translates the assembly language program into machine language. It creates object files which combine machine language, data, and information it needs to place instructions properly in memory. Often the assembler creates multiple files which need to be put together. This is where the linker, another part of the compiler software package, shines. The linker will take all the independently assembled machine language programs and object files and put them together. This produces a .hex file that the microprocessor can understand and run. Now, this figure, though it applies to C and C++ programming in general, is a good illustration of this process. Another piece of software called AVR Dude, and Dude is for downloader, uploader, starts when we press the upload button in the Arduino IDE. Now, this software sends the .hex file to the ATmega328 on the Arduino board. On the chip resides what's known as a bootloader. This bootloader was put there on purpose by the folks at Arduino and works with AVR Dude to get the .hex file into the flash memory on the chip. And all this happens very quickly and seamlessly behind the scenes of the Arduino IDE. Now, a few words are in order on this subject due to the enormous popularity of Arduino boards and the C and C++ language in general. Some of you use standalone or naked microcontrollers for your projects. After all, this is how things are actually made and mass-produced in the real world. And it's cheaper. We talked about naked or standalone microcontrollers versus Arduino in an earlier tutorial. Others use platforms or ecosystems such as the Arduino almost or entirely exclusively. Finally, some of you may use both depending on your goals and background. For hobbyists, the number of people who use platforms like Arduino has exceeded those who use only naked microcontrollers. When we talk about programming the Arduino, we'll talk about the C and C++ languages, but the truth is sketches are written in a language similar to C, though a sketch itself is not completely compatible with C. In Arduino, for example, the main function is hidden from view and added for you when you compile or verify your sketch. Also, there are two functions which the Arduino ecosystem absolutely requires, setup and loop. The only function C requires is main. C also lacks built-in functions for using microcontroller I/O, such as digital writes. To make learning simple, the Arduino IDE designers hide a lot of detail and functionality behind layers of abstraction, many of which come in the form of libraries. Note that the C programming language also uses libraries. They are added during the linking process. Though there are a few slight differences, if you can become a competent C programmer, you'll also master the Arduino IDE and crush it on your Arduino projects. And if you desire to port the code from Arduino to a naked micro, it'll be a cinch. Now that we know a bit about how high-level code converts to electrical signals a processor can use, our next video will talk about some C programming best practices to get you started. Hope to see you there! If you're interested in Arduino and microcontrollers, you'll love how to get started with Arduino in one day or less. Get instant access now by clicking the link below in the description.